Starting on January 1st, 2026, you could not install any new 410A split systems, indoor and outdoor unit together after that date. Well, now the EPA has came back and they've eliminated that, and they said you can install them and there's no cutoff date for that. So if they're in stock, you're allowed to install them as far as the EPA is concerned. Now, there's a caveat to that. Good afternoon, everybody. I'm Justin Sylsberry, Senior Director of Product.
Hi, and I'm JD. I'm McCarty. I'm Technical Advisor and Residential Trainer. As we always say, if you're on the job right now and have a question that's not regarding to our presentation here, call your distributor or our tech line. Our tech line phone number is 888-850-7928. Again, 888-850-7928. Otherwise, submit your questions anytime by using the question mark icon to the right. We'll be checking throughout the show and stopping and answering some questions.
Just a few notes. If you're watching us live, you're going to see the agenda on the screen along with a countdown timer that's going to mostly, hopefully, keep us on track. And of course, we'll have your questions throughout the show. So we will be looking at your questions and getting to those as time permits. And if you're watching on demand, we will have timestamps in the description so you can skip to the topics you're interested in. So let us know in the comments what more you'd like to learn. And remember, if you want to ask questions live, you need to register from one of two places. You can go to our website at greecomfort.com/GREE-training.
Or by using our app. If you don't have the app yet, scan the QR code that's up on the screen or search for GREE Contractor Pro on the App Store of Google Play Store. Or the next option, you could go to from the home page, tab Training and Events, tap Register. Once you're in, you'll have the option to watch and even ask questions live from your phone. All right, so let's go ahead and start talking comfort.
All right. First up, we'll be discussing comfort versus cooling. And this came up as a reading on our misnometer. And our misnometer says, if it hits set point, it's comfortable. Well, I think it's often common to focus on temperature, but humidity is what makes the space feel clammy, sticky, uncomfortable, or even uneven. So, for example, 72 degrees can still feel uncomfortable if the humidity is too high. And a lot of thermostats will read only temperature. They don't read comfort. So they won't always show you how sticky or humid a space is. Humidity changes how people feel heat. So high humidity makes the air feel warmer and heavier. Fast cooling can miss moisture removal. So if the system shuts off too quickly, it may hit set point without removing enough humidity from the space. So true comfort always means managing both temperature and humidity. So sensible and latent load together. So I think that's a really good topic here, JD. I know it all starts with proper sizing of the equipment. What do you say?
Oh yeah, it's funny we have this topic. I actually just took a call earlier on this. The guy said, he's like, man, it keeps meeting his temperature. They even turned it down a degree or two lower. He had 73% humidity in the home, but he's like, it's keeping temperature. He's like, I don't know what's going on. So house was, I think it was a FLEXX 3-ton. The house was 1,200 square foot. They had the outdoor set to 3-ton, the indoors a 2-ton air handler. They had that speed jacked up to 3 tons of airflow. So of course it just, like I told him, he's like, man, it doesn't even run very long. And I was like, well, it doesn't have time to remove that humidity. It's way oversized. It's a whole ton oversized. So it is prime example exactly what we're talking about. And of course it was meeting that temperature. They turned it down even to 70, 68, and they're like, we can't get that humidity out of here. They thought it was a defective unit. He's like, I was getting ready to rip this unit out of here. So yeah, I was like, this is going to go good with what we're talking about later today. I'm going to use this. So
that's a good point, because often you'll see this on single stage systems where people will come in and they'll eyeball the house or just go by square footage. They won't do a true load calculation, and they'll just go, okay, this house needs a 4-ton or a 5-ton, and they oversize it, and we'll when the system kicks on, it'll brute force the cooling and not remove the humidity. It'll cool that thermostat off really fast, but you leave a lot of humidity in the air. But it's important to note that this doesn't just happen with single stage equipment. It can also happen with inverter equipment. You know, so while an inverter can do a lot to help remove humidity, it's still very, very important to always do a proper load calculation and size the equipment for the application.
Oh yeah. And so that was the cool thing about it being a flex, Justin, is that we could, we have the capabilities of moving it to, it was a 3-ton unit, moved it to a 2-ton, moved up indoor fan speed down to 2 tons of airflow. And, his issue's resolved.
Absolutely.
So,
And
so that,
it may not even be a situation where, just the equipment can handle it. I know there's a lot of places, especially along the coastline, Houston, New Orleans, Miami, places where the humidity is so high, the latent load is so high that if you go into your extended ratings for the equipment when you're doing your equipment selection, the equipment can only do so much. There are certain situations where maybe you need to add a supplemental dehumidifier in certain cases.
right.
So it really depends upon your application and what you're dealing with. So again, it's always, always, always very, very important to do a full load calculation and then do proper equipment selection.
Right. Yeah. And that's actually the plus side of having an inverter too. We do have longer run times, a lot more capacities to choose from, which is gonna help with different size, different loads, and but kind of better manage it.
Yeah, absolutely. And your single or two-stage equipment simply can't do that. It's going to run at pretty much a fixed speed, and it's not going to be able to lower that airflow down and try to move the air slower across the coil so it removes more humidity like an inverter system can. So
Right.
definitely some advantages with the inverter equipment.
Oh yeah. And just how it's also based off set point too. So if it's only a couple degrees, it's not going to ramp that unit up, or if it's more than more than 4 degrees, it's going to ramp that outdoor unit up higher to achieve that set point. But it's still going to run for longer than your standard bang on bang off unit would too. So
Exactly. And I know we'll talk about more, about the inverter difference here in a minute, but you can always buy a thermostat. You can get a nice, Honeywell or whatever brand thermostat that'll actually show you the humidity. And you can do a relative humidity set point on that. But again, with single stage equipment, more than likely you're not going to have any change in airflow on the indoor unit. So what that system's going to do to try to hit a relative humidity set point, it's going to overcool, generally by 3 degrees. So,
right.
You set your relative humidity set point, the system overcools by 3 to 4 degrees, and the homeowner's sitting there freezing, as that system's
Right.
trying to get the humidity out. So again, not comfortable.
No, I deal with that sometimes too, where they put way too big of a head in just a bedroom. They put a 1-ton unit. You're like, what are you doing here? And they're like, oh yeah, it overshoots temperature. Well, okay, that's what it's gonna do.
Of course.
Why didn't you put in 7K or a 9K in there? Why did you put a 12K in just a 10 by 10 bedroom?
Yep. All right.
But
Well, I think with that, we're ready to kind of move on to our next topic and really get into the inverter difference and why, the newer technology matters. So, as we alluded to in the last conversation, inverter-driven systems are much more well suited to comfort control. You're going to get longer run times. You're going to have the variable capacity, variable in compressor speed, fan speed, refrigerant flow. You're going to have better load matching. And, JD's, like you said, you're going to have that less aggressive on-off cycling.
right. Yeah, and this ties directly to moisture and removal and why bigger and faster is not always better for humidity.
Exactly. So I guess we'll just run down the list. We talked about the longer run times. Well, how does that play into comfort? Typically when you tell people the system's going to run longer, they go, oh no, my energy bill.
Right.
Well, that's not necessarily true. Typically what happens is we can ramp down the hertz of the compressor, so it's pulling less current, using less electricity than a single stage system. When it kicks on, it's bang, it's on 100%. The inverter driven equipment can reduce its speed, reduce that current draw, and allows the system to run all the time while using less electricity. The advantage of that is we're having constant airflow across the indoor coil. So you're able to maintain a nice steady deadband of temperature within the inside of the house. And because you're constantly moving airflow across that coil, you're constantly removing the humidity from the air.
Right.
Whereas with a single stage system, it goes bam, kicks on, it's at 100% capacity. And, if the system's oversized, it's going to cool down the space rather quickly. It'll satisfy the thermostat and then it shuts off. And so you have these big spikes of, between the on off cycle of temperature going up and down and up and down. So, a lot of times, and I'll admit I kind of suffer in my house because I haven't I haven't gone through and installed a GREE yet in my house, where I've got a single stage piece of equipment, and between cycles, I go, man, it's getting kind of warm in here. And then about that time, I start thinking it's a little warm in the house. The air conditioner kicks on and cools it off. And then about the time it starts to wind down on the cycle, I'm like, yeah, it's getting a little chilly in here. So it's that constant up and down battle of being uncomfortable.
Yeah, we deal with that all the time too at my girlfriend's house. She's cold one minute and wants to take off her coat and then or her zip up, and then next thing you know, she's like, boy, now I want to put that back on. It's cold in here when it kicks back on, and it's not a comfort level like we're used to, with the GREE product. And also it helps too, that fan that fan continues to run and helps keep it more comfortable too, and keeps that air balanced rather than as soon as your traditional heating and cooling system shuts off, that fan shuts off, your heat rises, you're not getting that circulation either. So you'll have hot rooms and whatnot too. So, it all ties together.
Absolutely.
Let's see if we have any questions in here. Came in yet? No questions yet. So just a reminder, guys, the question mark icon at the bottom right of your screen. Any questions of what we're talking about or any input, anything you'd like to add, just go ahead and hit that question mark icon and send them our way.
Don't have any questions right now. I'll just I'll kind of reiterate again about doing proper manual J heat load calculation. You need to do your load for both heating and cooling, and you're gonna on the cooling side, you're gonna know how much sensible and how much latent capacity you need. And so then you need to do your manual S, which is your equipment selection, and you need to select the equipment properly to match your application. And where you're going to get that information is in our extended ratings. And our extended ratings will show you a total cooling number, sensible number. And from that, you can get the latent capacity. Latent is just total minus sensible, gives you the latent. So you'll utilize those extended ratings, which are available on greecomfort.com. Just use that information to go through and make sure you're matching the equipment properly to your application, because again, inverter equipment, so much better at trying to match the load in the space, but it only do that to a certain point. You can still oversize inverter driven equipment and have humidity issues. So please, again, I can't reiterate this enough. Do a load calculation properly and use the extended ratings to select the right equipment for your application.
Oh, what I was going to say too, isn't in some of the newer products, the submittal actually shows the extended ratings, and then the other older products, it's separate for the extended ratings.
Oh,
am I mistaken though?
Yeah, it's actually the other way around. In the old submittals, we used to include the extended ratings. We moved those into a separate document. The reason we did that is because the submittals show the AHRI rated capacity, and that's done at like AHRI conditions in a lab. And so sometimes, that number might be slightly different from what the extended ratings show. The extended ratings is actual like field performance.
Right.
And so people would get confused and they would always call or email us and say, well, which is the right number? This one's showing this and this one's showing that. So we split them out. That way there was no confusion. You always use AHRI numbers for your performance ratings, rebates, tax credits, things like that. But when it comes to your load calculations, go off to the separate extended ratings document.
Yeah, and depending on where you're at, you have to, size it by heat or cooling, depending on your region as well, right?
Definitely. Yeah. And
Yeah.
in cases like that where your heat load is 5 tons, but your cooling load is only 1 ton, well, we don't have a lot of equipment that can cover that wide of a range, right? So you may need separate equipment, one system for cooling and one system for heating. So it,
Yeah.
unfortunately, there's not a silver bullet for every application.
Yeah, well, I had one person, Justin, that, with the FLEXX, how we have strong mode and different modes, they were actually using, since they do a spring and fall check every fall, they were turning it on strong mode for the winter because they have harsh winters up in North Dakota and then mild summers. So then when they did the spring inspection, they were actually putting it to energy savings mode because they don't have that extreme summers. And that's kind of what they're doing for all their clients. And they were really seeing some savings there too. So just
Nice.
another added perk to, all the options that we have.
Yeah, definitely some good out of the box thinking that you can do with the inverter equipment.
Yeah. So now actually when I do my training, I tell them that, depending on the region, like, do this in your fall and spring inspection if you want to, just try to save your customers some money.
All right. I guess we'll move
Well,
on to our next topic called warm up, cool down. So in this, we'll talk about one of the most common residential scenarios we see. This is going to be a two-story home, upstairs versus downstairs comfort. As we all know, heat rises. And so because of that, you can always get complaints of air mixing, uneven temperatures. You can have humidity complaints, maybe more humid in the downstairs region versus the upstairs region. There could be questions about thermostat or sensor placement. Do we want to have two separate sensors, one upstairs, one downstairs, and average them if we only have one system, so on and so forth. And
zone it, not zone it,
exactly.
just do mini splits upstairs, regular downstairs or.
Yeah, and if we do, maybe do a mini split in one room upstairs, we got to really think about it thoughtfully instead of trying to treat it as like a magical one room fix, right?
Right. Oh
So
yeah.
as I was saying before, heat rises and sun exposure changes throughout the day. You get building diversity. Sun rises in the east, sets in the west. So your building load shifts over time. So upstairs spaces, they often need different comfort strategies than downstairs. And, it's just something to think about. I know weatherization plays a big part in that, but we'll just kind of skip that and leave that to the weatherization guys. Well, we're just going to
That's
talk
right.
about the equipment. So, JD, you talked about zoning. What types of zoning do you think you would use to address this issue?
Good question. So say in this example, since we're talking zoning, we'd have to probably be using our FLEXX or our FXU Ultra or Eco. What I always tell people is like, I recommend you when you do a zone, you want to try not to zone more than 50% of the time. And also, no matter when you do set it up, you want to ideally do a dump, not a bypass, because if you do a bypass, you're putting that hot or cold air right back over those sensors. And like with the newest FXU Eco and Ultra, They have sensors on there, so if those sensors get too hot, it could, cause that unit to ramp down, or, even, shut down temporarily just because you're putting that hot air right back over that coil, or cold air. So again, a dump is what I'd recommend, and then, making sure no matter what, if not zoning more than 50% of the time, and then making sure what your static is with those zones closed, making sure your dump is adequate.
Got it. And it's also important to think about the construction of the home when you're talking about zoning too, because there may not be room to do airside zoning, right? You may have to do full refrigerant zoning because refrigerant lines are much easier to fit in smaller spaces. So I mean, that's another consideration. Do you want to do a FLEXX system and try to zone it all with ductwork, or do we want to look at something like a multi-zone or multi-pro system?
Right.
It's easier to just do the refrigerant side stuff. And what's great about that is, it takes up less space, and you don't have to give any consideration to bypass dampers or dump zones, things like that, trying to mess with these zone dampers, right?
And that's just one more thing to go wrong, Justin, if you have those zone dampers.
That's true. You can get something to go wrong. You can get a motor failure. You can get a bad wire somewhere, and now you're you're
Yeah,
searching walls or in an attic trying to find where the short is, right?
absolutely. But yeah, good point. Yeah, you can just zone it with a multi-zone or a multi-pro, either one, depending on multi-pros are better for, if you have two longer line sets too, so we can go a lot further with those. And, so depending on how big your home is or how far you're trying to go, that might be better than a multi-zone as well. So,
Exactly. I think this is another advantage, again, going back to the inverter technology, inverter equipment, and how it's constantly running, it's constantly mixing airflow. Because again, as heat rises, it gets warmer throughout the day. As the sun moves across the sky, it changes the load within the house. Your inverter equipment is going to be running all the time. It's going to be constantly moving air across the coils. And so what's great about that is as the building load shifts, it's going to be constantly trying to keep up, trying to maintain that dead band evenly across the home. It's going to be mixing the air throughout the home much more evenly. And again, it's going to be addressing those humidity issues that can continue to pop up. So, yeah, I think when dealing with these upstairs hot and cold issues, it's not always a matter of, well, let's close a couple of vents downstairs and try to get more air upstairs, or add more ductwork. Maybe we need to start thinking more forward thinking more into the future, and start looking at things like the multi-pro, look at the multi-zone. Let's think outside of the box. We are constantly constraining ourselves to this centrally ducted
right.
technology, and it unfortunately it doesn't always solve our problems, or the solution that it does provide can be very cumbersome, time consuming, and hard to troubleshoot.
See if we have any
Um,
questions here. No questions yet, guys. Just remember the question mark icon bottom right of your screen. If you have any input or thoughts or questions, just fire away.
Nice. Looks like it's going to be an easy show today. We're not going to get bullied by any
Yeah.
questions.
Guess we're answering all the questions, Justin. We're just all
We're
right.
we're
So
just so much better than the other host, right?
that's right. Hey, hopefully they're not watching. So I guess we can go ahead and move on to our next topic. And guys, just remember the question mark icon. Let's see here. Commercial humidity. All right. Let's talk about light commercial situations where humidity, zoning, varying occupancy, and different room loads create comfort issues. This is where multi-pro and commercial VRF have a great impact. When the application needs flexibility, multi-zones, and better control than a simple single zone approach. And we were kind of just talking about that a minute ago, Justin. So, just kind of depends on the setup. Occupancy changes, comfort needs, of course, rooms that are empty compared to rooms that are full of people, once people gather in it. So you have to, factor that in when your calculations for your load. Offices, conference room, lobbies, and back rooms can all, need different levels of conditioning. That humidity control comes into effect. Not just about temperature, moisture, and runtime can drive those complaints.
Another important topic, and I talked about that in our last topic. This is where the building diversity really comes into play. And again, what I mean by building diversity is the shifting load throughout the day. And that includes not just weather, sun moving across the sky, heating up one side of the building versus the other. It's also the people load that shifts throughout the day. Maybe every morning, company opens, workers come in, and maybe they have a morning meeting in a big conference room. And so that conference room packed with a lot of people, they put out a lot of heat, so it gets much warmer in that conference room in the morning, and then they all shift out to their cubicles after that. So then the load in the conference room nosedives, right? Well, if you've got, just a big package unit running that room and it's on 100% or off 100%, it might struggle to keep up in the morning. Then in the afternoon, it's short cycling in that conference room area. Same thing maybe in the cubicle area. Another thing that you commonly see with commercial on package units are economizers. And, most areas people want those to be dual enthalpy controlled. So you actually get some humidity feedback into the controller. So if it's raining outside or something, it doesn't open up and suck in a bunch of humidity into the space. But unfortunately, a lot of times people go the cheap route and will just pick only the dry bulb controlled economizers, which aren't looking really at humidity. And so it could be 100% humidity outside and the economizer will still open if the temperature goes down far enough to try to get the free cooling. And now you've pulled in all this humidity into your space.
Yeah, good point.
Now, to be realistic, most of the time they'll set the economizers and pass the inspection, and then they'll screw them shut once the inspector leaves, and it never opens again. And then you get, sick building syndrome because everybody's dying of CO2. But
Right.
there are much better ways to deal with commercial humidity. And one of my favorite ways to deal with that is to take a VRF system. Because what's great about VRF system, it's multi-zone and variable speed, variable capacity. It can shift refrigerant load around a building to where it's needed, where you need that capacity. So in the morning, if everybody's in that conference room, the VRF system can send refrigerant, it can send capacity to that conference room to keep it nice and cool. And then when they leave and go to their cubicles after the morning meeting, it'll take that capacity, that refrigerant, and shift it over to the other side of the building where all the cubicles are. And then to really deal with like fresh air and humidity, I would like to have a separate DOAS system. Have the DOAS control just your ventilation to bring in fresh air, and it'll always bring it in at, what we say is a neutral air, which I'm trying to remember. It's like around 50% humidity, about 72, 73 degrees. So it's just dumping kind of neutral air into the system, and then the VRF system takes care of the comfort cooling from there. So that was one of my favorite ways to always address the commercial comfort problem.
All right. So question from Nick. It says, I have an area of customers that have two-story homes, probably built in the late 80s, or in the 80s or late 70s. These are aging out of their units, and I have been replacing with dual fuel and existing ductwork. Do you think a good add-on would be a condenser with a head in the garage or another on the second floor?
What do you think about the existing ductwork, JD?
Um, well, I mean, again, you you want to make sure that it's sized accordingly. We don't know how they did their load calculations in the late 70s or 80s, so I would it doesn't need to be re-insulated. Is it going in the attic space? Where's it going through? So might be a good idea just to, with a new system, run all new ductwork. Make sure it's sized exactly how you want it, so that we have proper airflow. Or it might be if it's a two-story home, you might have a good chase to run your refrigerant lines if you want to just do multi-zones. You already have a space to run those, and just use that ductwork as a chase to run your refrigerant lines and drains through. So
Yeah,
that was
I think again, a great point to bring up is this ductwork sized properly? We need to check the static pressure and make sure that it's okay to reuse the ductwork. And then again, to your heat load application or your heat load calculation, excuse me, for the application. And, because again, it sounds like from the question, they're wanting to put a head in the garage and another for the second floor. So I'm assuming, they didn't have any kind of cooling in the garage, but maybe the homeowner wants to have some cooling out there now, maybe turn it into a workshop. And perhaps, they got a hot spot in the second floor. So yeah, you could do a FLEXX system and a dual fuel application on the existing ductwork if the ductwork allows. And then to address that hot spot upstairs and the cooling in the garage, you can do that with maybe a 2-zone mini split. Again, if the load calculation allows for it.
right. Yeah. Good question, guys. Keep them coming. We have one more that came in from Ricardo. He says, I have a high ranch home with 2 floors. Each floor has its own thermostat, which are both paired with a zoning board that controls dampers for each floor ductwork. Essentially, one condenser and one air handler with one return on the second floor. Will the GREE FLEXX Ultra R32 be compatible with this zoning system with 2 thermostats? I assume I would not be able to utilize the RS45 T-stats as it may have complications with communicating with the GREE air handler condenser. Thank you.
Yeah, that is correct. In these kind of applications, you would have to use the 24-volt mode on the FLEXX. You would not be able to do the RS485 GREE controller because that would not be compatible with that zoning system.
Right. Yeah. And it all, if you're using the 24-volt side, then you can wire your dampers up however you choose, just like you would with any other 24-volt unit. So, so yes, it would be compatible as long as, depending on how you wire it and how you choose to, power that zoning board and the dampers and whatnot. Getting question mark icon bottom right of the screen, guys. Don't be shy. Ask questions. That's what we're here for. All right.
I guess they're not used to seeing me these days, so they're a little shy.
You're throwing them off. They're used to Greg up here, I think.
Yeah, Greg or James, one of the two.
Yeah.
All right. I guess we'll hop on to the next topic.
All right. Let's see. It's R410A rule change.
Yeah. So the EPA just kind of announced a rule change to their technologies transition program regarding R410A. So from what I've seen on May 26th, they just posted in the public register a change, and it affected refrigeration systems and HVAC systems. But we're not a refrigeration company, so we'll just talk about the HVAC side. But what it did was the EPA came in and said that they are eliminating the installation deadline for R410A split systems that were manufactured or imported before January 1st, 2025. So there is that import slash manufacturing deadline, January 1st, 2025. And then the installation deadline for those systems was originally January 1st, 2026. So that meant after, or excuse me, starting on January 1st, 2026, you could not install any new Fortinet systems, split systems, indoor and outdoor unit together after that date. Well, now the EPA has came back and they've eliminated that, and they said you can install them, and there's no cutoff date for that. So if they're in stock, you're allowed to install them as far as the EPA is concerned. Now, there's a caveat to that in that certain states may have laws on the books preventing new Fortinet systems from being installed. So even if the EPA says you can do it, you know, maybe New York or California, they'll say, nope, no more Fortinet after this date. It has to be one of the new A2L refrigerants. So in those cases, you'd have to follow the local laws. Also, it's important to note that this does not affect the deadline for packaged products. Now, the packaged products, those can be installed, I believe, until January 1st, 2028. So if you have R410A PTACs or package units, those can continue to be installed up till January 1st, 2028. Also, this rule change does not affect VRF systems. The deadline for the installation of R410A VRF systems is still January 1st, 2027. So again, this only affects split systems for residential light commercial applications. Okay. Also, another little important caveat is that between Hardy and ACA and some of these other organizations, they expect there to be a lawsuit. Maybe some states are going to sue the EPA over the repeal of this deadline. And if that happens, a federal judge could file an injunction against this rule change, which would put the deadline back in place. So, just got to keep that in mind. It's kind of a slippery slope dealing with R410A. As far as we're concerned, trade winds, we have sold through our R410A matched inventory. We've got systems, or indoors or outdoors, and we have parts for warranty. If you need warranty replacements, we can help you out with that. But when it comes to new match systems for brand new installs, we've worked through our 410A inventory. So, for our purposes, this change really doesn't affect us.
Right. All right. Well, thank you for that, Justin. Guess now we can get into our final segment. So let's look at a few questions and comments from our YouTube channel at GREE Comfort. Let's see here. So first one, stop guessing. Use GREE service tools to diagnose like a pro. So if we can put up there on the screen our test tools that we do have. We do not have one that works. I guess Tyler asked what tool is needed to diagnose the 410A FLEXX units. We do not have a designated tool for the 410A FLEXX. We do have one that's coming for the R32, FXU Ultra and Eco. And we do have the single zone troubleshooting tool, which you can actually use that to simulate and troubleshoot. And of course, you can use the single zone on a multi-zone. You just have to tie into each individual zone, or you have the multi-zone that actually plugs into the board. That is really just kind of more, again, you just plug it into the board and you can actually scan through and go through the different zones. You can see all the sensors and the EEB steps and all that. But again, when I do my trainings, I always tell people if you're going to put one in your van, for at least the single or multi zones, I would recommend doing the single zone because it does both, the single and multi. And I even have some videos on our website too that show me troubleshooting an E6 code with the single zone tester, and you can read the indoor sensors, the outdoor sensors, the EV steps, the hertz of the compressor. So there's so much information that these tools actually give you. And again, like I say, reading all the sensors, sometimes, if you have one zone that's acting up, you can, get in there and check the sensors to that zone. A lot of times that's why it's not feeding properly. But again, it just saves you so much time rather than, getting into that unit, unplugging those plugs and ohming the sensors. You just plug this in, you can read everything at once. So indoor and outdoor. So again, put one of these on your van. It's going to save you a lot of time.
Yep. Yeah. And unfortunately, again, we don't have a debugging tool for the R410A FLEXX system. That old model was 24 volt control only. It did not have a communication port. So we weren't able to release any kind of service tool for that. However, on the FLEXX R32 model, it does have an RS-45 port for full communication. And that service tool is in development by the factory. We don't currently have any kind of timeline on that. We're hoping sooner rather than later, but it is slated for release.
Yeah, but also, I forgot about mention this too, Justin. So that RS-45 controller, even if you're using it as 24 volts, if you run H1, H2, you can still check all that data on there. You can check, read the sensors from indoor and outdoor as long as you hook up H1 and H2. You can almost use that RS-45 controller that comes with the unit as your service tool. So that's what I tell people. You do actually have one. It's the controller that came with the unit, and especially if you're using it as communication, you just scroll through, a couple settings in there, and within, a couple pushes of a button, you have all the readings of your indoor sensors, outdoor sensors. It tells you fan speed, it tells you everything. So to me, you do.
Yeah, I mean that's a really good point. The GREE Communicate controller does provide a lot of information. Maybe not as much as a debugger or computer software
Yeah.
would. But you're right, it does show a lot of information on there. So from that, you could probably troubleshoot quite a bit.
And at least save you some time and some steps. But yeah. And then let's see what else we have here. We have a few more questions. All right. We have one from Mario. Says, I'm switching out an old Carrier air conditioning only unit, which is only 3 thermostat wires. For this unit, all I need is 2 wire to connect H1 and H2 without 24 volt wires, only if I use the GREE thermostat. So I guess his question is if he only needs 2 wires from indoor to outdoor, which actually, if you do look at the wiring diagram, this is again for the FLEXX Ultra, FXU Ultra, which is he's asking a question regarding the RS-45 controller, just for everyone listening. Of course, if you look at a wiring diagram, it does show R and C going to the outdoor unit along with H1 and H2. So we would need 4 wires from the air handler to the thermostat, and 4 wires from the air handler to your outdoor unit, H1 and H2 and R and C. Depending on if you have backup heat, then we would need a jumper wire from W, I think it is, right, Justin? I think that's what it was. Yeah.
R to W.
So again, your 3 wires, you are going to have to run a new wire. And ideally, what we always recommend too, you always want to run that communication wire separate every 24 volts, just to prevent anything from ever shorting or shorting out your communication. So you can use that wire for your 24 volts and just run a new 2 wire for your H1, H2. All right, let's see here. We have another question. So this one this question was, does the indoor unit also ice up? and it's basically we was troubleshooting a cross-wired or mispiped multi-zone mini split. So to answer his question, yes, depending on if you're in cooling mode and we're sending refrigerant to the wrong head, it will ice up. That's sometimes exactly how we know we have an issue. The fastest way I tell people when I get that call to try to, we have multiple zones and one's freezing up or, they haven't figured out what other one it is put them all in cooling mode. Turn to one head in question that's freezing up. Turn that head all the way down to 61. Turn the others up to 86. Go see what other zones are getting cold. Because if that one, if that one's getting cold, freezing up when we're not calling, turn the one that's freezing up down to 61, and it's going to actually send refrigerant to the other unit. So then if we have them all up to 86 degrees, go figure out which one, has a delta T, because it should be blowing out, all the others should be blowing room temperature out. So that's the fastest way. Or, if you ran your lines individually or your wires, then you can kind of track it out that way. But sometimes you go and hide a line and you have multiple line sets. So it's not the easiest way. Again, that's why I always stress when I do my trainings too is, mark your line sets. I know you have multiple people sometimes on these jobs, person inside, person outside. You have your helper, just be sure to, tape and label, tape your wires to your line sets and label them, use a different color tape for zone A, zone B, zone C, zone D, inside and outside. That way you don't get them mixed up. You don't get them crossed up, because I get this call multiple times a week. And, we have multiple techs. So it happens on a daily basis. So again, mark your line sets with color code them somehow, and prevent this from happening. But yes, they will freeze up. Let's see if we have any questions come in from those questions.
All right. Looks like we got one more question. Joe asks, do you need to use shielded wire for the FLEXX?
That is a good question. It is not required for the FLEXX unit, but you can use it. But again, it's not required. Main thing is you don't want to have any splices in that. So you do want to have a solid run from inside to outside. And we do recommend, it's not required to have a separate cable than your 24 volts. But again, that's just to prevent something from happening, that 24 volts from getting to your H1, H2 and shorting out your communication, then we'll be completely down. So, but that was a good question. I don't think we have any others, do we?
Nothing else has come in yet, so I think we're good.
All right. I think that's all the questions we have there too. So, all right. Well, that does it for this month's Talking Comfort Live. We do have a few announcements here. So check out what's coming up with GREE on Wednesday, July 8th. Topic is high static and hot attics, working through restrictive ductwork. And then GREE Contractor Pro app is available on the App Store for iOS and Android. Scan the QR code on the screen to download, or go to the App Store, Google Play, and search GREE Contractor Pro. So again, just to kind of talk about this app for a second, you can find submittals, you can find service manuals. Again, we put our air code tool, all of those air codes, almost every one you can possibly get is, we have an air code tool in there that we actually made improvements on. We kind of made it to where instead of going back and forth, go back to step 6 or go forward to step 10. We actually put a yes or no, is the voltage this? It's yes, you go this route, no, you go this route, then it asks you more questions. So we tried to make it, bulletproof to where you get to where you want to be, you get the issue resolved, you get all your answers. This is good for after hours, even while you're waiting for us to give you a call. I don't know how many times I call the contractor back and they're like, oh, I already figured it out, I just used your app. On the weekends, after hours, really, if you just, you're in a bad service area and you can't get phone service, you know, and you at least get enough service to use your app. So again, so many good things you can find there. You can even find our videos. You can even tune into this through your app. So anything to add to that, Justin?
Nope. I'll just check one last time if you had any other questions come in.
All right.
Looks like we're good.
Good deal. Be sure to register for the upcoming show on our website from the app, greecomfort.com/GREE-training. Give us a like, subscribe on YouTube, and join us for next month's Talking Comfort Live. And remember,
at GREE,
we're by your side.
Please like or subscribe to our channel at GREE Comfort on YouTube and head over to greecomfort.com/training for more tips and tricks and all the information you need to help you out in the field. And that was a good show.